Okay, so for your motors to run or to make it more precise, you can also use because as we say in it earlier in the servo motors, we only talk about only one coil, two coil, three coil, four coil. We only talk about four coils. Alright. Nonetheless, you can also have more than that. Alright, more sets. Actually, now over here, this is actually one set of. This is the one set. This is the second set, right? So this is only two sets of coils. But normally we will have four sets of coils and six sets of coils. Alright. So the higher the sets of coils you have, the more precision you have. So you can have more angles. Over here, as we can see, we actually have a 90 degrees just now, right? In the previous video. So now if you have happened that we talk about 4 sets, alright, then each of the angle is actually 45 degrees. Alright? How it works is like this. This is set 1, this is set 2, this is set 3, this is set 4 coils. Okay, so if happen that if I on the first set of the coils, alright, and this is north, this is south because it's magnetic. So if I were to coil this, alright, if I were to connect it to a current, alright, then you actually generate a north and south pole, alright, and your motor will actually turn here. Okay. Now if I were to switch, alright, I were to off this coil 1 and I on coil 2, alright, then the motor will actually turn to here. You see? And then if I were to off a set of 2 and then I on coil 3, if I were to off coil 2 now, or the set of coil 2, alright, now I on coil 3, then it will actually turn to here. Okay, so over here there is 2 steps, you see. So each of this side is actually 45 degrees, 45 degrees, total up is 90 degrees, right? So this is just exactly what it's trying to say lah. Alright, nonetheless you can also turn on coil 1, alright, and coil 2 together. Okay, so the resultant would be that the motor will actually turn in between coil 1 and set of coil 1 and set of coil 2. Okay, so you'll be in between them. Alright, so this is how you use your motor lah. So this is actually what they're trying to say with this picture. Typically we will on 2 coils or 2 sets at one time. Alright, so I on 2 sets, coil 1 and coil 2, and then after that it will turn to here. Alright, the next time if I were to turn, then I'll on coil 3, set 3 and set 4. Okay, and the motor will turn to here. Okay, so you'll keep on turning like this all along. Okay, so the reason behind having 2 sets of coils turn on at each time is because you have provide a greater torque. Alright, so if you only turn on one coil, alright, the torque itself isn't very big. Alright, so if you turn on 2 coils, you can actually increase the torque, so you have more power for the motor. Alright, so over here this is what they say lah. So only one coil active at each time, you reduce the current, but so reduce current means you save the power, but you also reduce the torque. Alright, that's the meaning of that. Alright. Next is that the half step is the one that I've told you, I think, that you turn on both of the coils. You turn on set 1, alright, and you turn on set 2. Alright, so the motor itself is in between coil 1 and coil 2. Okay, and that I don't know, actually I don't know what the hell is this talking lah. I'll leave you to think about it. And then the system in the sketch. So it says that your coils has to be energized in both directions. Alright, so I think the both directions is that you require power generated from this point and this point. So you need 2 sides, 2 directions. Alright, so you have a power that generate to the north, to generate a north pole, and over here to as a south pole, so that your motor can actually move to here, or your rotor, I should say, your rotor, or your fan blade or whatever, your blade or whatever can actually move to here. Okay, for the head of your motor, normally you have a certain system, right? Let's say 5 volt, and then you have a head, and then you connect the head with maybe a fan blade or whatever. So over here, the head over here is the one that is turning. Alright, it can turn here, it can turn here. Alright, while the coils, the coils within is actually within this particular system over here. Okay, so I hope that this is pretty clear for you to understand. Alright, take note that your stepper motor cannot be operated too quickly because it requires time to actually accelerate and decelerate. So over here, so therefore normally you want to create, or nonetheless this is also prone to mechanical resonance, and this frequency must be avoided. Alright, mechanical resonance I think is vibration. Alright, so you actually cause vibration if you accelerate or decelerate too quickly or whatever, so you vibrate quite a lot. So you may want to control these things quite easily. Alright, so nonetheless, therefore if you want to control this easily, alright, one method is that is this. Alright, you're operating in terms of a unipolar. Unipolar means I think is two directions. So you have coil 1 and coil set coil 1s and set coil 2s together operating at one time. So for example, at this section over here, coil 1 and coil 2 is actually on. Alright, so coil 1 and coil 2 are on. So therefore the motor, the head is actually turning in this direction. Okay, and then after that, at the next time step, alright, over here coil 1 and coil 2 is on. You see coil 3 and coil 4 is off. So therefore the head is turning in this direction. Alright, facing in this direction. Alright, and then at the next time step, alright, you see coil 2 and coil 3 is on. So therefore coil 2 and coil 3 is continue to be on. So they will actually, the thing will actually turns here. So previously it was here. Alright, the new position will actually move to here. Okay, as you can see. Alright, so this is telling us that this thing over here is setting it to be here. Alright, as you can see. Then the next time step, I'll use a different color. Alright, your coil 3 and coil 4 will turn on. So coil 3 and coil 4 will turn on. So you'll move to here. You see? And then after that, up to so this is, yeah, coil 3 and coil 4, is it? Wait, over here is coil 3 and coil 4. So over here now, new one is coil 1 and coil 4 will turn on. So coil 1 and coil 4, which is this one, so you'll turn to this direction. Okay, so you keep on turning and turning and turning, so you'll keep on spinning. You see? So this is how it's being used lah. Okay, hopefully I explained quite a fairly bit well. Alright, so this is how the pulse is being do. So therefore each of the coil you will have its own power generator. Also you input a certain power to the coil. So each of the coil has its own set of power. Alright, maybe I have just draw this lah. So each of them has their own power supply. Alright, so as you can see, it's pretty clear over here. Each of the set of the coils has its own power supplies. Alright, so therefore this is just the thing that just wanted to say. And why do we use the two set of coils at one time is because you want to achieve a good torque. Alright, so nonetheless you may require higher current lah. Alright, so what we'll be talking is also only talking about the waveform to actually drive a stepper motor. Okay, so we're talking about only the definitions of the stepper motor. Alright, so next we're gonna talk about the control of the stepper motor. So how normally do you control is that you control using a clock frequency. Alright, and you generate a clock frequency for maybe, I think, your SCL, if you talk about the I square C, I think, I don't know whether is it linked or not, but you require a clock to actually help you to compare or to track the motion of your motor. Right, because you have waveforms over here. Alright, your waveforms require a time. So each of the time you need a clock to actually help you to compare the time between the turning of your motor and the time from your Arduino. Alright, because we are currently controlling these impulses using your Arduino. So your Arduino has to have a time that is synced to the clock or the turning. So your Arduino must have a clock that is synced to the time that is turning, the actual time that the motor is turning. Alright, so I think, yeah. And generation of your waveform to provide desired movement. Alright, so this is what we have been saying. These are the waveforms that you require. So first you require the clock, alright, which I've said, and then the waveform that I've shown you. Alright, and nonetheless you also need powers. So your powers, you can use the dilating drivers or the H bridge that we have say earlier in the earlier parts over here, the pulse width. So remember what if you want a DC motor to go in two directions. Alright, so you can use a Darlington's method, or the H bridge. Alright, where which is turned on, which is turned off. Alright, if you still remember, the H bridge is this one. Okay, if you don't understand anything, then I would suggest that you go and watch this video, L8E3 V8e8, or you can watch the Darlington pair and the drive load, and and MOSFET. Alright, MOSFET, and you can watch these 3 videos lah if you're free lah. Okay, because in the future, if you happen that you need it lah. Anyway, we got still a bit of a long way to go, and nonetheless, specialized integrated circuits can help you to run your motor. Okay, and then so within the IC itself, the integrated circuit has a clock, alright, to clock waveform to define your frequency, alright, to help you to compare with your actual frequency in the real turning part. Alright, it will help you to decide stop or go, or forward or backward, or half step or full step. Half step or full step means half power or full power. Alright, and then forward meaning you turn forward or you turn backward, or directions and things like that. So the IC itself helps you to define all this stuff. So you may require 2 ICs, a translator IC to generate the waveform, and a second IC to actually drive the motor. So I repeat again, the IC is actually called the integrated circuits, where you put in whatever thing that you want within the particular circuits, so that the circuit board will do whatever thing that you want it to do. Alright, so if you want to know more about the motors, you can actually go to this particular websites to check it out. And over here you can go, and then I think I'll leave you here. Alright, next video we'll talk about the range and other stuff, talking about the last part of the motors. Alright, so I shall see you in the last part of the motors then.